Hello everyone, and welcome to our series of Learning to Code with P5. Today in this video, we will be talking about parameters. Parameters is something that we have been using with pre-existing functions in P5. But in this video, we will learn how to set up our own parameters for our custom functions and how this will give us more control and personalizing our functions when we call them in the draw loop. So let's get started. Okay, so before we begin, I want you to let us go back to this reference page, and I want you to revisit these parameters that we have been working with, right? So think of this rectangle. For instance, we have been working a lot with the X and Y position and width and height just to define what kind of rectangle we want and where we want it, how big or small its width and height needs to be. For the purpose of this exercise, what we will try and do is we will try to create our own custom shape. Okay, so now if we see all the shapes which pre-exist in P5, what we can see is that we can create some kind of a circle, either an ellipse or a circle. We can create lines and points. The max we can go up to is like 4-sided shape, which is either a quad or a rect or a square. And of course, like a 3-sided one, a triangle, but we don't have anything beyond that, which is what if we want to create a pentagon or a hexagon or so on and so forth, right? So we are sort of limited, but we don't need to feel limited because we can create our own custom functions, and that's what we will try to do today. And we will try to set up parameters within our own built function that will help us control not just where we can create that shape, but also how many points of shape that we want, right? Like if we want to create a pentagon or if we want to create an octagon and so on and so forth. So we will have better control over that. That's one thing. The other thing that I want to talk about is basically in order to actually create our own custom shape, we will use few more functions which pre-exist in P5, namely specifically this vertex function. So what is vertex function? What it does basically is think of it like a point. So it needs X and Y location to figure out where it needs to go, right? So that's one thing. But with vertex, what you can do is that you can create any kind of shape that you want. It doesn't have to fit or confine to either a rectangle or a hexagon or whatever. It can be a totally arbitrary shape that you can create. All you need to know and define is different sort of points from where it will draw the shape. So one thing that you need to remember is that the vertex actually always is sandwiched between beginShape and an endShape. Of course, in these examples that we can see, there are hard-coded numbers which are put here. So it's either a point or sort of like a diamond sort of rhombus shape, or a bit more complex, which is more like a star-ish kind of a shape. So these are all possible by having more, by knowing where the X and Y position is, and that we can fit into the vertex, and then we can sandwich it between a beginShape and an endShape so that it knows where to go. So that's one thing. Well, that's the second thing. The third thing that I want to talk about is in order for us to figure out different points and make them more dynamic so that they can be used later on and we can assign different sort of values, we need to know a little bit about, we're going to talk about a little bit of math here. So we will talk about, have I missed it? About some trigonometry here. And we will be talking about a couple of functions that we will use. We will not get into the details, but I just want you to know that we will be using a cosine and a sine function here. These are already existing there. All we need to do is use these functions with an angle and we will get our desired results. So now that we know that what we are sort of going to be doing for a shape that we will create, let's talk about how we will create that shape and what we need to understand in order to better create that shape. So let's take this pentagon as an example. So we'll first try to create a shape which has 5 corners, right? A pentagon. So if we need to create this kind of shape, we can do this in a very, well, I don't want to say like simple, but we can simplify the process by actually utilizing a circle. And how can we do that? So think about it. If this pentagon, let's say, is confined within this circle, all we need to know is basically what exactly are the points on the circle that will help us figuring it out. So that means that, we need to know the X and Y location of each of these points on the circle so that we can create our pentagon shape, right? And something that we just were talking about were a couple of things, right? A, we will of course need to put it in a vertex kind of function. Why? Because we will need to know the X and Y position. And in order for us to calculate the X position and Y position, we will take a deep dive into this circle. Okay, so let's look at this one. So this circle is basically called a unit circle. And what that means is that this is a circle which has a radius of 1 at this point in time, okay? Don't worry about it. We won't be doing a lot of math here. This is just a very simple sort of way for us to remember when we are trying to calculate X and Y, okay? So if this is a unit circle with a radius of 1, we can use cosine function and a sine function with an angle inside. Okay, so what exactly does that mean? So angle, first of all, here is represented by theta, which is like a Greek letter used mostly in trigonometry. How we can calculate the angle is that if of course, the circle is a 360 degree, right? So if we started from here, this point, and we go all the way, this is 360 degree. If we know the angle between the line or the radius that goes all the way from the center, which is 0, 0 location, all the way from where to where we are drawing the line. If we know the angle, we can use that angle in the cosine function and the sine function to calculate the X and Y position. One thing that you really need to remember is that cosine function is always going to be used when we are trying to calculate something on the X coordinate, and sine function we will use with the angle if we are trying to calculate something on the Y coordinate. So those are the pretty much two things that we need to take away from it. But it is important for us to know because we are dealing with vertices. And of course, when we are talking about pentagon, we are, let's say, talking about 5 vertices. So we need to understand from the center position 0, 0, whichever the vertex is going to be. So we need to figure out the X and Y. We will use cosine function and a sine function for it. Okay, and we will determine our angle around that. So now that we kind of understand this basic idea, we can actually move to our code. Oh, but one more thing. Okay, so we are talking about this unit circle, which means that it has a radius of 1, right? Radius all the way from this to the edge of the circle, right? But let's say if this is not, it doesn't have a radius of 1, then what, right? All we need to do is basically multiply this by whatever the radius is, and it will give us the same sort of value for that circle, right? So imagine if the circle is not, if it has a bigger radius, instead of 1, it has 10. All we will do is we will put the cosine function with the angle, sine function with the angle, and then multiply with the radius. So then it will be calculating the X and Y position of that particular circle. All right. So now that we know, we will first create the center point in our code, and then we will actually try to move it to the edge of the circle that we will be imagining, and then we will put 5 of these as vertices, and we will be able to create our shape. So that's just like a big summary of what we will be doing in our code. So let's get started. All right, so here we are. Now that we have discussed around what we will be doing, let's start by creating a point at the center, which will basically be a small circle, right? And then we will try to plot them on the bigger circle with a certain kind of radius, and we will be able to create our own shape. So in order for us to do that, first of all, we know that we need to create certain variables. and that we will be needing those variables to determine the angle, and that we can use it for our X and Y thing. So let's say, first of all, we will create our angle. Remember, our angle by default is calculated in radians, which is basically a value in pi, or if you want to do it in degrees, of course, we need to change that. But for now, let's just call it pi divided by 4. What that means is basically it's 45 degrees, okay? Angle. So that's one thing. The other thing is that we will need to create variables for X and Y, right? Because that's what we will be needing it. And if we remember from our discussion here that we will be using the function for cosine, right? And this function, literally like this, needs to have an angle inside. Now our variable is called angle, so that's what we are putting here. And then we will do the same thing for y, but with the sine function, okay? And here we are going to put our angle inside it, all right? And then what we will do is basically create our circle and use the variables here. For now, we'll just create a smaller-ish circle with a radius. And I'm gonna do one more thing. I will basically I'm going to keep this here, and now that we can see it a bit better. So if you can notice, I've put this, of course, I haven't defined it starting from the 0, 0 point. What we can do is we can basically, let's say we can translate it with half of width and half of height, and then we can have it at the center of the screen. Well, not the screen, I mean the canvas. Okay, so now that we have this point, so this is kind of the 0, 0 point, right? Because we have translated it, that means that our canvas has moved its origin, and it has become at the center. Well, we've moved it to the center, so now the origin point 0, 0 is starting from there, okay? So this is something that we kind of understand so far, right? We know how the translate function works. We know that the cosine function and the sine function will help us determine the X and Y location. And we have been able to create it for this one. Okay, imagine if we were, first of all, this is at the center point, right? Now we need to move it to the edge of the circle that we are imagining, right? So we can decide whatever the radius of that circle is. So let's try and create a radius of the circle to the edge of which one we will actually start plotting our vertices. So let's just, I'm giving it for now a hard-coded number. Now that I've decided the radius, first of all, I have to make sure that I am multiplying it with the radius. So that's important. Because without that, it will just be calculating it for a unit circle with a radius of 1. So that's 1. Okay, now that we can see that it has moved from the center all the way here, right? And why is that? Because remember, 0, 0, we had our first point, and now I've moved it to the edge of the circle that way. Since we can't see it that much, I can just give you an example. So imagine if it was just 100, you will see it here. If it's 200, it's here. But maybe a good idea could be if, let's draw a line. I'm doing 0, 0, which is the starting point, which is half of the width and half of the height. And then here I can move it X and Y. So now you can see that from this point here, it has become here. And now somewhere around like this, that's how big our circle is going to be, because this is going to act as our first vertex, okay, on this circle. And a good idea that we can kind of think about is that imagine if we want to see how big the circle is, maybe instead of giving it a 45 degree, we can map it, right? We know how to map it, right? It can help us do a lot of things. Let's just map it to our mouse's Y coordinate. So that way what is happening is, of course, if we are taking our input value as mouse Y, that means we are going all the way from 0 minimum value to all the way to height. And then I can move it 0 to all the way 360 degree, and 360 in pi is going to be 2 pi basically. So now let's, and this is how, from where the circle actually starts, right? If you remember from the image as well that I just showed you, that's from where it will help us calculate. So now if you look at my cursor, which is at 0, 0, well, not 0, 0, but in the sense like y is 0. If I just move it along the y-axis, it is completing one full circle, right? So that's what it is doing. All right, so now that we kind of know this, you can now have an idea of how big the circle is, right? Because it's kind of rotating along that. So what we can do here now is that we need to, first of all, when we are talking about pentagon, that means that we are creating 5 vertices. So how can we do that? We, first of all, okay, now we don't need this technically. We will put a vertex function and we will use the x and y inside. And for each vertex, we have to, well, I'm going back and forth, but it has to start off with a beginShape and an endShape. All right, so if we have this here, and I will, okay, you know what? I'm going to pause this for now and not talk about this. Let me go back and show it to you in circle and with lines, because that's something that we can already see. Okay, I kind of jumped ahead. Okay, so let's go back here and first try to create 5 vertices. Okay, what do we need to do for that is that we will do our for loop. So I'm going to, for now, put this inside. And of course, we need to say, okay, let I is 0, I is less than num side, and then I plus plus. That also means that I need to define the num side as well. And what that means is that I will do, for now, I will do let the num side be 5. Okay, and just give me a second. Okay, so if this is happening, first of all, I think that our translate function will go super crazy. And oh no, or maybe I should. All right. Nope. I'll keep this outside for now. And what I will do is that I am going to move this here. And okay. So yeah, my bad. Here, I forgot to change this. So, okay, we need to, when we are creating our for loop, we need to create it, pass this variable inside. So instead of 0 and height, what I will do is I'm going to say that, okay, take this variable and then spread it out, or like create it 5 times on 5 times is because something that we have decided here in terms of the value that we have given. And also the input value is I, which is we have defined here. So what we are saying is between 0 and 5, spread it out on the circle, which is going from 0 all the way to 360. Okay, that was a bit back and forth, but it worked out fine. Okay, so far, does this all make sense? I hope so. Now that we can already see the circle in its fullest form, fullest in the sense that we can literally see that if these are our 5 different vertices, Now we can actually, let's say if we kind of combine them, it will give us a pentagon. And how we can kind of do this is that if we will do a beginShape and an endShape, and then this one vertex is going to replace this line and circle, which was just there for our visual reference initially. And I'm going to comment this out. All right. So what is happening if you see, remember, if I comment this out, you can see all these vertices, right? Like these are the points, different 5 points. So starting from this first one, remember, because our circle was moving all the way like this. So this is our first point. From here, this vertex has gone here, 1, 2, 3, 4, 5. But the thing with this begin and end shape is that it has actually connected all of these vertices, but it starts from the first one and then ends here, which is the last vertex. But if you need to actually close it, that means that close it in the sense that join the last one back to the first one. There is an argument that we need to put in the end function that's called close. And it has to be in all caps lock because that's how it is intended to be. So make sure that you always do that. So now that you can see that it has actually created, and now I can comment this out, and it has created a pentagon for us. All right, now that we have created our pentagon, what we can do is basically use this entire thing that we have created and customize it, create its own function, and then we can kind of call it and use it whenever we please. So let's call it a polygon, just so that we can control different number of shapes. Before I do that, let me just show you, because here we have defined the num side. Remember, we have said 5, which is why it is creating a shape of 5. But if we say 7, it's going to change the shape with 7 vertices, right? Again, why? Because it is being defined here, right? Like I is less than whatever the num side is. That means that this for loop is helping us create it again and again, and create what? Basically these vertices, right? So how many vertices we define is being right now controlled by the num side. So if we make it 9, it's going to be this. If we make it 3, then it's going to be a triangle, right? We are just going to keep it 5 for our sake at this point in time. And now what we can do is basically go back, and I'm going to move this here. And in order for us to actually now see it in the draw function is we need to call it, right? Something that we kind of know already. So do not make spelling mistakes, because otherwise it won't show up. All right, so now we have created this polygon shape. But what has happened at this point in time is that we have created, first of all, we've created a certain radius we decided in this function, which means that we cannot customize it when we call this function, right? Every time it's going to be this kind of big shape that polygon is going to be created, regardless of like we can't customize in terms of like stroke or fill values and everything. So what if we pass some kind of parameters here, just like how we have been think of it like, I don't know, circle here, right? So here we have x, y, d, which is telling you specifically that it is the x coordinate of the center of the circle, y coordinate, and then the diameter. We can create our own as well. So let's try to define the center of this shape as well. So that way what we can do is we can use to create things inside, and give the arguments inside, and then we can create where it would be created, and then we can give multiples or more of these ones. Okay, what else can we give to customize it? Maybe we can give how many, what kind of shape, right? So if we can make it variable in terms of setting up the parameter, when we call it in the function, we can create, we can control if it's going to be a pentagon or if it's going to be an octagon or something else, right? So a very simple way, first of all, is that let's say if I use this num side, I'm going to pick it and I'm going to drop it inside here. And then I cannot do a let function, first of all. And why is this happening is, and I'm going to put 5 inside here, and then it will come back. Okay, let's take a step back. What exactly happened here is, if you notice, I put the variable name here. What that is doing is, when you are actually setting up a parameter within your own custom functions, anything that goes within the parentheses, which is basically your parameters, is where you are declaring that variable, right? So here in this one, because I removed this let thing happening here, this is where your parameter gets declared. This is where you assign the value, right? Because here I'm telling it when I call the function is basically do 5. And then here it is being used, right? Back again in the function, wherever the num side has been defined, that is where this assigned value is being used and reused. So this is a step that you will always need to remember. Sometimes it can be confusing, but remember, this is where we declare our variable, which is going to be set as the parameter. We assign those values when we call the function in our draw one. And then later on, wherever that variable has been used in that function is where that value is going to be used or passed on, basically. All right. Again, if I remove this 5 here, this function is not going to work because it is expecting an argument, most likely something that we will also be able to see in our console. Hopefully. Well, it's not showing up, but of course it's expecting an argument, so that's why it hasn't. It is not popping up on our screen. So that's 1, or I can do 3, right? And you can see it is changing based on whatever I'm assigning the value. All right, so that's 1, but this is just 1 argument. I'm going to remove this, or not, to avoid confusion. So that's num side. The other thing is that, okay, what about the center X and Y position? So let's just say, okay, we'll try, okay, first of all, make sure that you're naming it properly, because we have already used X and Y to define the vertex's position. We are not going to use it. We will call it center X and center Y. All right, and here it is saying that it is defined but not really used, etc., etc. So here what I can do is, again, the order of the parameters is super important. So if I have said that the first argument needs to be center X, if I use this as the first argument and then I add something onto it, it will take up 5 as the center or the X position of the center of the shape. So I have to be mindful of that. But let's do a mouse X and a mouse Y, right? And then keep it 5, which means that I should have this one as following my mouse, but technically it isn't. And why do you think that is? Okay, so the reason is because I have used, or I have declared the variable here, but I haven't used the variable anywhere in my function. So it doesn't know what to do with it. So what I need to do is I need to replace this with center Y. Sorry, I started with the caps. So that way, okay, so now if you see, if I've just replaced one value, you can see that it is following wherever my mouse's Y position is, but it is not following the X position because it needs to be replaced. So I will say center X. Again, remember, and now it has started working. Remember, here we are declaring the variable. Here we are assigning whatever that value needs to be. And then somewhere in the function, wherever it is used, it is going to be using that value. So now this is how it is kind of sort of working and translating, right? So that's one thing. Now imagine, again, because this is a custom shape, okay, maybe let's add one more argument to it. So now if you see, as much as I would like to create, I can only control where this shape can exist on the canvas, and I can only control the number of sides that it has. But what I cannot control is how big or how small it is. So let's try to add a radius thing here. So what we can do is I will move radius as an argument here, which is our fourth argument, and then I'm going to remove this. Okay, remember, this is already defined here. That means that it has to work with it, and now it is expecting, I'm sorry, not the background, but this is expecting our fourth argument. So imagine if I make it much smaller, I don't know, make it 50, too small? Nah, it's okay, right? So now what I can control is not just the shape, but also where it is located and how big or how small it is. And of course, if we start using up the fill and all those functions, we can control more things around that. So let's just try and create another one. Call it again, and this time we will use maybe, okay, width divided by 2 and height divided by 2. And then, I don't know, let's do an octagon, which is 100. All right, now if you look at it, something is happening. Although what I have asked here is that I want it to be at the center of my canvas, it is not actually at the center of my canvas. My first one is actually following my mouse. The second one is sort of already offset. So any idea of why this is happening? Like, you can pause and think. And if not, let's try to figure this out. This is all happening is because what we have done is we have used the translate function. And remember, the translate function is cumulative, right? So what it is doing is that since I called it with the mouse X and mouse Y for the first time, the next time what it is doing is it is using mouse X and Y as the origin point, and then it is moving half of width and half of height from that point. So you can see this is still following my mouse, but it's actually offset by half of width and half of height. So it's not exactly where we want it to be. In order to kind of rectify that, what we can do is, what we will do here is that we will sandwich it between our push and pop. Why? Because this way, whatever happens to one of the functions stays with that only, and this one is not being impacted, right? And again, if you notice that my this pentagon is kind of overlapped by this octagon, because this has been created first and this is created later on, but now it doesn't matter, right? Like, for instance, if I use this first, let's say, because I want the movement to be still like visible and all that, I can totally do this as well. And if you want, you can definitely, you know, assign different color values and stroke values to control your shapes. So what has happened is, just make sure, and I'm kind of reiterating, of course, now you're able to create your own custom functions. You're able to use the variables to create your own parameters and set them in your custom functions, and then reuse them when you actually call the function in draw loop. One thing that I would also remind you of is that sometimes if it's too difficult for you, you know how the parameters, or like what the parameters stand for, are declared in, let's say, here as well. If there are too many of them, or for whatever reason you want to keep notes for yourself, you can always put them here. Of course, comment them out first, so that way you remember what you're actually using them for. So I can literally say center location of the shape, and then num side is defining number of corners shape has, and then the other one is radius, which is quite obvious. So I'm not going to put it in this one for now. But yeah, so this is totally how it can be done. So I would let you explore more things. Maybe you can think about creating some kind of your own custom shapes or objects using other functions that you've learned so far, or variables and loops and all the learning building blocks, and then customize it and see how that kind of goes. So see you in the next video.